Hello students, Namaste to everyone. Today we are going to discuss about elevation of boiling point of solvent. The elevation of boiling point of solvent is one of the colligative properties. What is the colligative properties? Means the properties of dilute solution which contain non-volatile solute depends on number of the solute particles like ions, molecules and moles, but it does not depend on nature of solute particles. Such properties is called as colligative properties. There are four colligative properties are there. One is relative lowering of vapor pressure. We already discussed before lecture in video. Second one, elevation of boiling point of solvent. Third one, depression of freezing point of the solvent. Fourth one, osmotic pressure. Now we are going to discuss elevation of boiling point of the solvent. Before the elevation of boiling point of solvent, we discussed about what is the boiling point. Pure solvent like a water taken into the vessel. This vessel keep on flame. Initially, we do have water vapors at room temperatures. This is atmospheric pressure. But there is atmospheric pressure which do not allow the water vapors. But there is atmospheric pressure which do not allow water vapors moves up. We start heating. As the temperature increases, then molecule having more energy, then we find number of vapors being formed. Okay, now the temperature at which the vapor pressure of solvent becomes equal to atmospheric pressure, such temperature is nothing but boiling point. So vapor pressure is equal to atmospheric pressure. Such temperature is nothing but boiling point. So what is the meant by boiling point? The temperature at which the vapor pressure of liquid becomes equal to atmospheric pressure is called as its boiling point. If vapor pressure is equal to atmospheric pressure if vapor pressure is equal to atmospheric pressure, the whole of the liquids start bubbling, moves up. Okay? Look here. What is the boiling point? The temperature at which the vapor pressure of liquid becomes equal to atmospheric pressure is called as boiling point. Now, look here. Do you know that vapor pressure of liquid is directly proportional to 1 by boiling point? Look here. When non-volatile solute is added to the pure solvent, then vapor pressure of the solution is decreases. So pure liquid taken into the vessel non-volatile solute like urea, glucose added to the solvent, then vapor pressure of the solution reduce or decrease or lower. That means the vapor pressure of the solution is lesser than vapor pressure of pure solvent. Pure solvent. Now, the graph drawn in between vapor pressure and temperature. Now, the graph drawn in between vapor pressure and temperature, based on this graph, we will explain elevation of boiling point of the solvent. Okay. Now, the graph drawn in between vapor pressure and temperatures. Do you know that vapor pressure of solution is lesser than the vapor pressure of pure solvent? Vapor pressure taken on y-axis, temperature taken on x-axis. Temperature taken in terms of Kelvin on x-axis. So do you know that atmospheric pressure, which is equal to vapor pressure of the liquid, such temperature is nothing but its boiling point. So this is the 1 atmospheric pressure. This line indicates 1 atmospheric pressure. So do you know that vapor pressure of pure solvent is higher than vapor pressure of the solution? So this curve indicates vapor pressure of pure solvent. Now we can draw vapor pressure of solution. Generally, vapor pressure of the solution is lesser than vapor pressure of the solvent. So the vapor pressure of solution curve drawn under the pure solvent curve. This is solution, which is contained non-volatile solute. This line draws like this. This point indicates boiling point of pure solvent, this point. Now the line drawn like this. This point indicates boiling point of solution. Here T naught B indicates the boiling point of the pure solvent, TB indicates boiling point of the solution. We observe this graph. The boiling point of the solution is always greater than that of boiling point of pure solvent. That means the increasing of boiling point is nothing but elevation of the boiling point. So this indicates elevation of boiling point, which is denoted by delta TB. So based on graph, we can say the boiling point of solution is greater than that of boiling point of pure solvent. So that is TB is greater than T naught B based on graph. Okay. So the difference in between these two is nothing but elevation of boiling point, which is denoted by delta TB. So delta TB is equal to TB minus T naught B is nothing but elevation of boiling point. Elevation of boiling point. The elevation of boiling point delta TB is directly proportional to the concentration terms of solutions. They have they have more number of concentration terms there. First one is molarity, molality, mole fractions, mass percentage, volume percentage. These are the concentration terms for solutions. Here delta T is directly proportional to concentration of the solution. Now I am telling you delta TB is directly proportional to the molarity concentration. Molarity. Why we are taking molarity means the molarity does not depends on temperature. That's why we are taking here molarity concentration term. So delta T is directly proportional to molarity. Delta TB is directly proportional to small m. Small m indicates molality. Now look here. Delta TB is directly proportional to small m. Delta TB is equal to Kb into molarity. Here Kb is the proportionality constant. Proportionality constant, that is also called as molar elevation constant, are also called biblioscopic constant. So come to here. Delta TB is equal to Kb into molarity, number of moles of solute, that means Mb. Here solution containing two components. One is solute, one more is solvent. So it is non-volatile solute, it is taken as a B components, it is taken as A components. Number of moles of solute by weight of solvent in kgs. Look here. Now delta TB is equal to Kb into Nb converts into the weight of the solute by molecular weight of solute. Weight of solute by molecular weight of solute into 1000 by weight of solvent in grams. Okay. Here delta TB is the elevation of boiling point, KB is the molar elevation of constant, WB is the weight of the non-volatile solute, MB is the molar mass of solute, WA is the weight of the solvent. Okay. By using this formula we can calculate molar mass of non-volatile solute. Okay. Now I am taking this equation. Delta TB is equal to KB into molarity. If M is equal to 1, then delta TB is equal to KB. That means the elevation in boiling point of 1 molar solution is called as ebullioscopic constant. Okay. Now look here. Here KB is equal to R into molar mass of solvent into T naught B square by 1000 into delta H evaporation. This is the formula for KB. Actually, there is no need for derivation of KB. So KB value is different for different components of solvent. Okay. Now units of KB. So do you know that delta TB is equal to KB into small m, that means molarity. I want to KB is equal to delta TB by small m. So what is the units of delta TB? Kelvin, temperature. So units of molarity is equal to moles by kg. So the units of KB is equal to Kelvin kg mole inverse. This is the units of KB. Now come to here. Delta TB is equal to KB into molarity. This equation for non-electrolytes. This equation for non-electrolytes. For electrolytes, delta TB is equal to I into KB into M. Here I is the Van factor. I is equal to number of ions for solute. Okay. Now problems. This problem based on elevation of boiling point. Now we are going to discuss these problems. Okay. Look here. A boiling point of benzene is 353.23 Kelvin when 1.80 grams of non-volatile solute was dissolved in 90 grams of benzene. The boiling point is raised to 354.11 Kelvin. Calculate molar mass of solute. Kb for benzene is 2.53 Kelvin kg mole inverse. Here benzene acts as solvent. So boiling point of solvent T naught B is equal to 353.23 Kelvin. Boiling point of solution, how much is given? So look here, the boiling point rise to means boiling point of solution 354.11 Kelvin. Based on these two, we can calculate delta TB. Delta TB is equal to TB minus T naught B. So that is equal to 354.11 value for delta TB. Now weight of solute, how much is given? 1.80 grams. Okay, molecular weight of solute we can find out from data. Weight of solvent, how much is given? 90 grams. So do you know that? Look here. Delta TB is equal to Kb into weight of solute by molecular weight of solute into 1000 by weight of solvent in grams. All these values substitute in this formula to get a MB value. Okay, look here. So I want to MB is equal to Kb into WB by delta TB into 1000 by weight of solvent in grams. Look here, Kb value 2.53 into WB value 1.80 into 1000 by delta TB value 0.88 Kelvin into weight of solvent 90 grams. Simplify them to get here 57.5 grams. This is for molecular mass of non-volatile solute. This is the today our sessions. Thank you.